Hello students. Our next series of discussion is on chemical bonding. We are going to discuss ionic bond in this session and then covalent bond in the next. When we think about chemical bonding, the first question that comes to our mind is, why do atoms combine with each other to form a molecule? The driving force behind combination of atoms to form a molecule is stability. Stability of a system is generally associated with the lowering of energy of the system. So, when atoms combine and form a molecule, it means that the resulting molecule is more stable than its individual constituent atoms and has a lower energy as well. The elements of group 18, which are known as noble gases, are known for their inertness. That is, noble gas atoms show very little tendency to react with other atoms. This lack of reactivity is attributed to the fact that noble gas atoms are already stable and have low energy, which cannot be further lowered by the formation of new molecules. Why is it so? Low energy of noble gas atoms is associated with their having outermost shell which is completely filled with electrons. This arrangement is also known as noble gas structure. Let us see what makes a bond. Normally, outermost electrons of an atom participate in bond formation. So, outermost electrons of two or more atoms are involved in formation of a bond which results in a molecule. After bond formation, each atom has a more stable configuration than what it previously had. Also, the most stable electronic arrangement is a noble gas structure, and many atoms attain this structure after bond formation. Note, however, that transition elements form molecules which are less stable than this arrangement. The atoms can attain a stable electronic configuration, that is the noble gas structure, in following one of the three ways. First is by losing electrons, second by gaining electrons, and the third is by sharing electrons. Now, based on which method they use to attain a noble gas configuration, the elements can be divided into three types. First is the electropositive elements. These are the elements which can easily furnish or lose an electron. The second type are the electronegative elements. These are the elements which can easily accept an electron. And the third type are those elements which have very little tendency to gain or lose electrons. This table illustrates the type of bond formed when atoms of different kind of elements combine. For example, when an atom of electropositive element combines with another atom of electronegative element, ionic bond is formed. When an atom of electronegative element combines with another atom of electronegative element, covalent bond is formed. And when atom of an electropositive element combines with another atom of an electropositive element, metallic bond is formed. Ionic bonding involves complete transfer of one or more electrons from one atom to another atom. Covalent bonding involves sharing of one or more electrons between two atoms. And in metallic bonding, valence electrons are free to move throughout the crystal. We must bear in mind that the above three types of bonds are idealized in the sense that generally molecules show character of one or more bond types. For example, lithium fluoride is an ionic compound, but it is also soluble in alcohol, which suggests that it possesses a little covalent character as well. Very few bonds are purely ionic, covalent, or metallic. Most are intermediate between the three main types. Now let's start with ionic bonding. Ionic bonds are formed when electropositive elements react with electronegative elements. Let's consider the case of sodium chloride, that is NaCl. The electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. We observe that the first and the second shell are full and the third shell has one electron. When sodium atom reacts, it does so in such a way so as to attain noble gas structure. If sodium loses one electron, the resultant electronic configuration will be 1s2, 2s2, 2p6. Here, the outermost shell, which is second shell, is completely filled. Also note that this is the way electrons are configured in neon. So by losing one electron, sodium attains a noble gas structure which is more stable. Also, in doing so, sodium acquires a net positive charge and is now called sodium ion. So as you can see in the equation, sodium, which gives sodium ion plus an electron. The positive charge arises because sodium nucleus has 11 positively charged protons, each having a unit positive charge. Whereas after losing one electron as in its ion, it now has only 10 electrons, each having a unit negative charge. So the net charge which remains on sodium ion is 11 minus 10, that is 1 positive charge. Now let's come to chlorine atom. The electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. This is only one electron short of noble gas configuration of argon, which is 1s2, 2s2, 2p6, 3s2, 3p6. So when chlorine reacts, it tends to gain one electron in order to attain noble gas structure. So as we can see in the equation, Cl, that is chlorine atom, plus an electron will give Cl minus, that is chloride ion. So when sodium and chlorine react together, the outer electron of sodium ion, that is this 3s1 electron, is transferred to chlorine atoms, forming sodium ion and chloride ion. These two oppositely charged ions are now held together by electrostatic attraction in a crystalline lattice. This is what we called ionic bond formation. As we can see in the figure, sodium atom contains one electron more than the noble gas configuration. If it loses its outermost electron, it will have 8 electrons in its outermost orbit. Similarly, chlorine atom, which has 7 electrons in its outermost orbit, consists of 1 electron less than the noble gas configuration. Therefore, sodium atom will tend to lose an electron to form sodium plus ion, and chlorine atom will tend to gain an electron to form chloride ion. The two oppositely charged ions will be attracted by electrostatic force of attraction and will form an ionic bond to form ionic sodium chloride. Now consider the case of calcium chloride, that is CaCl2. As we can see in the configuration of calcium, that calcium atom has 2 electrons in its outermost shell, that is these 4s2 electrons. And after losing these 2 electrons, it can achieve noble gas structure. Whereas chlorine atom, as we have already discussed, is 1 electron short to attain noble gas structure. So calcium atom loses its 2 electrons, and each of the 2 chlorine atom accepts 1 electron to form 2 chloride ions. Now these oppositely charged ions, that is 1 bivalent calcium ion and 2 chloride ions, are held together by electrostatic force of attraction in a crystalline lattice. The example of calcium chloride is quite similar to that of sodium chloride. Calcium atom has 2 electrons extra to the noble gas configuration, so it will tend to lose 2 electrons to form a dipositive calcium ion. The chlorine atom, which has 7 electrons in its outermost orbit, will tend to gain 1 more electron to have 8 valence electrons. The calcium ion and the 2 chloride ion will attract each other through electrostatic force of attraction and will form ionic calcium chloride.